In this hopefully short video, we're going to investigate how the inverse square law can be thought of and various effects on forces of attraction and spacing when we change some other variable. So here we have two masses, m1 and m2, separated by a distance r, and we have some force F acting mutually on each of them. So that's the baseline consideration. And let's see how these various proportionalities, inverse square, proportional m1 and m2, are affected by changing something else. So first, let's look at the inverse square relation. And so in terms of F, in terms of this original force with separation r, what happens to that force? What happens to this? When the separation is not r, but actually quadruples, it becomes 4 times as much. Hopefully you realize right away, well, it gets less. And if you're not thinking too hard about it, you might just say 4 times less. But the problem is we're making this number 4 times as big and we're squaring it. So now it's only a 16th as much. That's how the inverse square law works. So if you cut it in ninths, that's the next one, 1/9 r. Well, it gets stronger, but not just 9 times as strong. But when you go 1/9 and you square that, you get 1/81. So that becomes 81 times as strong. Invert and multiply. What's the force when the separation is 2.5 times? Well, you put 2.5 squared, and you can either do that in your head or on a calculator, and out pops 0.16 times the force. When the separation is 0.3, of course it gets bigger, so 0.3 squared, and see what that does when you invert it. You get 11.1. All right, that was pretty easy. Let's see how r is affected by difference in force. So it's basically the same thing, but now I'm going to solve for r, 1 over square root of the force. So what's the new separation? What's the new r? If the force is 9 times as much. Obviously it has to reduce, but it's not reducing by 9 times. We can just really solve for it. If you make this 9 times as much, then the square root of 9 is 3, and you get 1/3. You cut the radius in thirds. What's the new separation if the force is now 1 over 36 times the original F? So the force has gotten much less, so you have to separate it out. But the square root of 1 over 36 is 1/6, so it becomes 6 times as much. Isn't that fun? You want to do a few more? Well, good. Let's do one more slide of a few other proportionalities. So this time, let's look at the direct relations, namely that the gravitational force is proportional to each mass. So in terms of the original force, what new force is between those objects if the mass of object 1 doubles? Well, since it's just proportional, it just doubles. All right, what's the new force if the mass of both objects double? Well, times 2 for this one, times 2 for that one. What's the new force if the mass of object 1, this one, increases 3 times? The mass of object 2 increases 4 times. 2 times 3. 4. 3 times 4, right? 12. What's the new force if the mass of object 1 increases 6 times? 6 times as much. Okay, that makes the force 6 times as much. Mass of object 2 decreases by a factor of 4. So 6 times as much, 1/4 times as much. Bring them together, you get 1.5. Now the new force is 4F. And the mass of object 1 is 1/3 as big, but the result has to be 4 times as much. So you got to multiply 1/3 by something that makes the result 4 times as much. Okay? So if you wanted the end result 4 times as much, basically you have to do 4 times and then do that 3 times. Do the 4 times 3 times to get rid of the third, if that makes sense. And then you get 12 again. 12 times 4. I'm sorry. 12 times 1/3 is 4. Now, Let's do the composite, namely all of them at the same time. What's the new force if M1 doubles, M2 doubles, and R doubles? Let's see, 2 times 2 divided by 2 squared. The same original force. Now we're going to increase M1 by 3, increase M2 by 8. See, 3 times 8, 24. Increase R by a factor of 4. 4 squared is 16, so you got 24 over 16, 1.5. Finally, M1 is quartered. All right. M2 increases by a factor of 3. Ooh, now we got 3 force up here. R1 is 1/6 as big. So 1/6, you square that, you get 1/36. Invert and multiply. So you have 3 force up here times 36, 27. 27 times the force. So there's some examples of how that works, and hopefully you feel like you have some facility with that at this point.